Hi guys, welcome to this set of videos. Again, what we're doing here in this chapter, which is chapter 6, is we're eventually going to get to a point where we're going to begin to look at radicals. But for now, here in section 1 and now here in section 2, we're sort of looking deeper into this idea of functions. And again, I promise you, we'll connect all the dots and it'll make perfect sense why we would start this chapter taking a look at functions prior to a discussion on radicals, which will come in a little bit later section. But for now, here in chapter 6, section 2, what we're going to do in this set of videos and over this, this section of notes is we're going to take a look at inverse functions and relations. So a couple of objectives or learning targets for you, things you should be able to do by the time we get to the end of this set of notes. You're going to want to be able to find the inverse of a function or a relation, so we'll start with that. We'll show you how to find an inverse function or an inverse relation. It's a very simple process. And then the last thing we're going to have you do is determine whether. I'll give you two functions and ask you functions or relations and ask you to determine if they're inverses. So those will be our two objectives or learning targets. And let's kind of start this discussion with this idea right here. What does it mean to be an inverse? So what I've done is I've just given you a simple example here having to do with units of measure. We know that one of the customary units, SI units, is going to be meters per second. However, here in the United States, we do not use the metric system, so we don't use meters per second. We generally measure speed in miles per hour. Now, there is a fairly simple conversion to go back and forth between the two. So the first function that we're going to get is a conversion that will allow us to go from miles per hour to meters per second. So what I do is I start off with how fast am I going in miles per hour? Miles per hour, right? So that X just represents, you're doing 60 miles per hour, 70 miles per hour, 80 miles per hour. How fast are you going in miles per hour? Then we'll convert miles to meters, right? So I put miles on the bottom, so miles and miles will cancel. I'm going to convert to meters, and there happens to be 1,600 meters in a mile. The next thing I need to do is get rid of hours and convert that to seconds, which of course is a very easy conversion. Hours will cancel with hours, and then there are 3,600 seconds in an hour. So miles cancels with miles, hours cancels with hours. I'm left with meters per second, and what I have is a way to convert from miles per hour to meters per second. All you have to do is take how fast you're going in miles per hour. You multiply that number by 4, then divide by 9, and you will have your speed in meters per second. But what if I wanted to go the other way? What if you knew your speed in meters per second and you wanted to convert to miles per hour? Well, I show you that here for the function g of x, but you guys are smart enough to know, right? If to go from miles per hour to meters per second, right? Miles per hour to meters per second, I multiply by 4 and divide by 9. If I want to go from meters per second to miles per hour, you just do the opposite thing, right? Do the inverse relation, right? Which is exactly what the function g of x shows us. In order to go from meters per second, where meters will cancel with meters, seconds will cancel with seconds. I'm just showing you the conversion here. You come out, converting from meters per second to miles per hour is exactly the opposite. You multiply the number by 9 and divide by 4, which is exactly what we would expect. You just, to go from miles per hour to meters per second, you have to do a certain operation. To get back to meters per second, you would just undo what you had done. So multiply by 4, divide by 9. To go the other way, multiply by 9, divide by 4. This is a great example of inverse functions or inverse operations, and exactly what we're going to be looking at here in this set of notes in the example problems we're about to do. But instead of doing conversions from miles per hour and meters per second, we're going to take a look at functions. Finding an inverse function just simply means that you will have two functions that undo each other, right? If I take a number and add 3, the inverse function would be to take that number and subtract 3. If I have a number and I multiply it by 10, the inverse function would be to take that same number and divide by 10, right? You're just undoing what one function does, right? So you have a function that does something to a number. The inverse function will undo what the previous function did. So a couple quick things for you here to highlight on this set. This is it right here. The function g of x does the inverse operation of f of x, and that's really the point. F of x and g of x are inverse functions. They undo what the other one did. They're inverse operations. So let's go ahead and take a look at an example problem on the next page by looking at inverse relations first. Now remember, a relation is simply a set of ordered pairs. Now finding an inverse relation is incredibly easy. The set of ordered pairs obtained by reversing the coordinates of the first set of ordered pairs. So here we go. I give you an example right here. All you're going to need to do, the domain of the relation becomes the range of the inverse, and the range of the relation becomes the domain of the inverse. Really, really fancy way of simply saying this: switch. The x and y values. Right? The x and y values just switch places. That's all you're going to do. So here's a great example. Q is equal to the coordinates 1, 2, 3, 4, 5, 6. To find the inverse of this relation, you just switch the x and y values. So the 1 and 2 switch places, and the inverse relation 2, 1, right? They just switch places. My next ordered pair is 3, 4. To find the inverse, you switch places. So the inverse would be 4, 3. I have the point 5, 6. To find the inverse, the x and y switch places, and I get 6 and 5. So what I'm telling you here is that the relation Q and the relation S are inverse relations because the x and the y has switched places in all of the coordinates. And we actually have a special notation for that we'll talk about in just a second. But for now, that is our inverse relation. So here we go. I have an example problem for us here. We're going to go ahead and do this one. What I want you to do is graph. What I'm asking you to do is graph both the relation that you have been given, which happens to be a triangle, and find the inverse relation, and we'll graph both of them. Well, since I already know, right, it's going to come out to be a triangle. You have 3 points. You connect the dots. You got yourself a triangle. What I'm going to do is we'll go ahead and call that relation T. So I have the relation T, which is equal to 2, 1, 5, 1, and 6, 5. All right, so that is my relation that I have been given. And let's go ahead and graph those guys. You know what? I'll do this one in, we'll do this one in red. So I have the point 2, 1, 2, 1, 5, 1, 5, 1, and the point 6, 5. And I'll go ahead and connect those dots so that you can see the triangle that is the result of graphing that relation. Now, what I asked you to do is to find the inverse relation, and we just talked about a second ago. To find the inverse relation, you simply switch the x and y coordinates, which we'll do, but we have a special name for it, and here's what it is. To find the inverse relationship, we call it by writing the same name, right? This is my relation, which I've called T. The inverse of T is what we name T to the negative 1 power. Now remember, here's the reason why. Let me explain to you why that's the name we use. Here it is. When you talk about inverses, what you generally are talking about is flipping a number, right? If I give you the number 4 and ask you for the inverse, right? Hang on a second. Actually, let me write it like this. It'll make way more sense. Let's do this. I'm going to give you a number, and then you give me the inverse. So if the number is 4, you guys know the inverse of 4 would be to flip that fraction, right? This is technically a 4 over 1, so you flip it, the inverse would be 1/4. If I gave you the number 2/3, right, you know the inverse would be to flip that guy, you'd wind up with 3 halves, right? That's how you find an inverse. You just simply flip it. Well, if I gave you a function or a relation t, what is the inverse of t? Well, it would be, right, flip that fraction, it'd be 1 over t. But instead of writing it, let me slide up a little bit so you can see it. Instead of writing it as 1 over t and calling the inverse relation 1 over t, we have that neat little property of exponents we talked about a while ago. And that property is this one that says you can bring a variable or a number from the denominator to the numerator by changing the sign of the power, right? So since that t is in the denominator and I want to bring that t to the numerator, I can do that by changing the sign of its power, which is to the first power. So that is the same as t to the negative 1. And now you know why I call the inverse relation t to the negative 1. What I'm finding is 1 over t, or the inverse function, and we call it t to the negative 1 thanks to that property of exponents that says when you bring something from the denominator to the numerator, you just change the sign of its power. Now, how do I find that inverse relation? Well, it's just as simple as switching the x and y coordinates. Since the first point was 2, 1, my inverse point would be 1, 2. Since the second point was the point 5, 1, the inverse would be 1, 5. And the last point was 6, 5, which means the inverse would be 5, 6. All right, so there I go. I have my relation that I was given. I have found my inverse relation by switching the x and y values. It's just that simple. And I'll graph this one in, let's see, what have I got here? I got a green. All right, so let's go ahead and graph these guys. I need the point 1, 2 right there. I need the point 1, 5 right there. And I need the point 5, 6. Which is right there. Connect those dots. And I've done exactly what the problem has asked me to do. I have found both my inverse relation and I have graphed both the original relation and its inverse. All right? So it's just that simple. If you're given a relation, a set of ordered pairs, you can find the inverse by simply switching the x and y coordinates. Just swap the x and y to get your new ordered pair, and that will represent your inverse relation. Head on over to the next page of the notes and we'll take a look at how you find an inverse function. So I'll meet you guys there.